Okay, so we're going to have a go at using the variant effect predictor in Ensembl. So we've got VEP up here at the top, or here as well. So if I click on the link, I do have options here to download the standalone script, but I'm going to click into Launch VEP, which will open the online tool for me. So it opens up this, this job, and I'm going to put a title in for this job. So I'm going to put H3A Bionet demo as my title, and I can put in my data. I can either paste it in or I can upload a file. So I'm going to choose file, and it's this genomics file that you should also have available to you. And this is going to use Ensembl transcripts. I've got these collapsible menus of extra stuff that I can select. One of the things I am going to add is HGBS notation to my output. But I can get various other kinds of identifiers, such as UniProt identifiers, if I'm interested in that in my output. It's going to find co-located variants for me, and it's going to find frequencies from 1,000 genomes, but I could get frequencies from other sources as well. And I'm going to get things like transcript biotypes, transcript support level. It's going to get me SIFT and polyphen, both prediction and score, and other things as well. One thing I can do at this stage is filtering. I prefer not to filter data at this stage. I prefer to run it all through and then filter after. But I can do things, if I go into advanced filtering, I can filter by things like manual allele frequency, if that's what I want to do. But I'm going to go back to no filtering, and I'm going to hit run. So this refreshes every 10 seconds. You'll see this is my job here, the VEP analysis of H3A Bionet demo in Homo sapiens. I can save this to my account if I want to. I can edit it, and I can also share it, so I can send this link out to anybody who I want to see my data. You see that it's currently running, and when this is this keeps on refreshing, and eventually it will tell us it's done. Okay, now it says done. I can go into view results, and here I get a summary of my data. So I get all the consequences of the variants that I've found. So I get a pie chart of all of them, and also the ones that are just coding. It tells me how many it's processed. So there were 261. 4 of them are novel, most of them were existing, and we've overlapped 240 genes. If I scroll down, we can take a look at some of the lines on this table. So we can see we've got the identifier of the uploaded variant that was in the VCF, its location. We've got the allele of the variant, and we can see that this one is an intron variant in this gene CAMTA, and this is its Ensembl ID. As I scroll across the table, I can see which intron it's in. I've got HGBS notation for this. If I scroll further, I can see that it's an existing variant. I could click onto this variant and find out more if I wanted to. And there's allele frequency. So because this is an intron variant, I don't have things like amino acid and protein position, but this is where they would be in, say, a missense variant. I've got allele frequencies from 1,000 genomes. And this different variant here, you can see I've got PubMed identifiers. So we've got lots and lots of information here. If I just show you a missense variant, so I'm just going to filter here by consequence is missense. And now we can see we've got a missense variant. As I scroll across, we've got protein HGBS, we've got an amino acid change, we've got codons, and we also have SIFT and polyphen scores for these as well. So you can see that most of these are tolerated, but this one is possibly in this particular transcript. I can also download my data or put all the variants or genes that I found directly into Biomart if I wanted to investigate them further. So we've now got a quick exercise on using the VEP. After that, we'll have a look at how you can actually use these data for variant prioritization.